Look up at the sky right now. It is blue. A deep, vivid, impossibly beautiful blue. Now, astronauts floating just 100 kilometers above your head look down and see black. Pure black. Infinite black. Same sky. Same location. One is blue. One is black. How is that possible? You have seen the sky your whole life. You have never questioned its color. But today that changes. The sky is not just blue. It is a clue. A clue to one of the most beautiful tricks in all of physics. And once you understand it, you will never look at daylight the same way again. Welcome to Why. Before we answer why, we need to understand what light actually is, because it is not what most people think. Sunlight looks white, but it is not white. It is everything. Inside every beam of sunlight, every single ray hitting your face right now, there are millions of colors all traveling together. Red, orange, yellow, green, blue, violet, all mixed, all moving at the speed of light. We know this because of a simple prism. A glass prism splits sunlight into a rainbow, revealing all the colors hiding inside what looked white. But here is what makes light strange. Each color has a different wavelength. Red light has long, lazy waves. Blue light has short, rapid, energetic waves. Think of it like ocean waves. Some are gentle and spread out, some are tight and choppy. This difference in wavelength is going to explain everything. Now meet the atmosphere, the invisible ocean of air wrapped around our planet. And this is where the magic happens. The atmosphere is full of tiny gas molecules, mostly nitrogen and oxygen. Billions upon billions of them, stacked 100 kilometers deep above your head. When sunlight travels from space toward Earth, it has to pass through all of these molecules to reach you. What happens when light hits a molecule? Scatters. The molecule absorbs the light and re-emits it in a new direction. But not all colors scatter equally. Short wavelengths, blue and violet, scatter much more than long wavelengths like red and orange. Blue light crashes into molecules and bounces off in all directions. Red light mostly passes straight through. This phenomenon has a name, Rayleigh scattering, named after the British physicist Lord Rayleigh, who figured it out in 1871. Blue light scatters approximately 5.5 times more than red light in our atmosphere. So as sunlight pours into our atmosphere, blue light bounces off every molecule it meets, filling the entire sky with blue. No matter where you look, east, west, straight up, blue light has been scattered there. The sky is blue because the atmosphere is a blue light machine, scattering blue everywhere all day long. If the sun is pouring light in all directions, and there is light everywhere in space, why is space completely black? The answer is surprisingly simple. Space has no atmosphere. No atmosphere means no molecules. No molecules means nothing to scatter the light. In space, light travels in a straight line. If you are not directly in the path of a light beam, you do not see it. The sun blazes just 150 million kilometers away, but the space around it is black because the light passes through empty space without hitting anything to scatter it toward your eyes. On Earth, blue light bounces off millions of molecules and reaches your eyes from every direction. That is why the whole sky glows blue. In space, no bouncing, no glow, just pure black. The sky is blue because we have an atmosphere. The universe is black because it does not. Here is the most surprising thing about the blue sky, and almost nobody knows this. Violet light scatters even more than blue light. So why is the sky not violet? 3 reasons. First, the sun produces less violet light than blue light to begin with. Second, our atmosphere absorbs some violet light at high altitudes. Third, and most fascinating, our eyes. Human eyes are much more sensitive to blue than violet. Even when violet is there, our brain interprets the mix as simply blue. The sky is blue partly because of physics, and partly because of the way human brains process color. Now sunsets. At midday, sunlight travels a short path through the atmosphere. Blue scatters everywhere. Sky is blue. But at sunrise and sunset, the sun is at the horizon. Sunlight has to travel through 10 to 40 times more atmosphere to reach you. Almost all the blue light gets scattered away before it arrives. What is left? Red, orange, the long wavelengths that refuse to scatter. They survive the long journey and hit your eyes directly. This is why every sunrise and sunset is painted in warm reds and golds. Earth's atmosphere is a color filter, and it changes the filter depending on where the sun is. If the sky color depends on the atmosphere, what do skies look like on other planets? Mars has an atmosphere, but made mostly of carbon dioxide with fine red dust particles. The dust scatters red light instead of blue. The Martian sky is pink-red at noon and briefly blue at sunset, the exact opposite of Earth. Titan, Saturn's moon, has a thick nitrogen atmosphere like Earth, but loaded with orange haze particles. The sky is a deep orange-brown. Every world with an atmosphere has its own unique sky color, determined by what that atmosphere is made of. Our blue sky is not the universe's default. It is Earth's unique signature. And here is a beautiful bonus. Why is the ocean also blue? Partly because it reflects the blue sky, but also water molecules themselves absorb red and orange light and scatter blue, much like the atmosphere does. So Earth from space is a blue planet for two reasons: a blue atmosphere and blue oceans, both blue by the same underlying principle. When astronauts first saw Earth from space and called it the blue marble, they were seeing Rayleigh scattering from above. The whole planet wrapped in blue physics. So, why is the sky blue when space is pitch black? Because blue light has short, energetic wavelengths, and those short waves scatter when they collide with the tiny molecules in our atmosphere, filling your entire sky with blue, no matter where you look. Because space has no atmosphere, no molecules to scatter light, so light travels straight through the void, invisible until it hits something directly. Because our sun produces more blue than violet light. And because human eyes are built to see that scattered mix as blue. Because at sunrise and sunset, the long light path strips out all the blue, leaving only red and gold. And because Earth, this one pale blue dot in a black universe, happens to have exactly the right atmosphere, made of exactly the right molecules, scattering exactly the right wavelengths, to give us the most beautiful sky in the known solar system. We live under a miracle of physics, every single day. If this video made you see the sky differently, subscribe to Why. Next week, we ask why stars twinkle but planets do not. Two lights in the same sky, completely different behavior. The answer is hiding in physics again, because why is always worth asking.